Welcome to This Academic Life, episode 64. If you're interested in being a sponsor, then please contact us at sponsor@thisacademiclife.org. Hi, my name is Kim Michelle Lewis. I'm a professor of physics and associate dean for research.
Hi, my name is Lucy Zhang. I'm a professor of mechanical engineering.
Hi, my name is Pania Newell. I'm also a professor of mechanical engineering. Allen Waterman Award is a prestigious and highly competitive recognition in the United States given by the National Science Foundation. It is named in honor of Dr. Allen T. Waterman, the first director of the NSF, and it was established in 1975 to recognize outstanding young researchers in the fields of science and engineering. The award is one of the most significant honors bestowed by the NSF. The Waterman Award is presented annually to an individual who has demonstrated exceptional scientific and engineering achievements and significant contributions to their respective fields. It's open to scientists and engineers from various disciplines and seeks to highlight the innovative work of researchers who have the potential to shape the future of science and technology. Today, we are thrilled to introduce one of the 2023 Waterman Award recipients, Dr. William Anderegg from the University of Utah, a scientist of remarkable distinction. William, welcome to the show and congratulations on this amazing achievement.
Thank you so much. I'm quite excited to be here with you all.
Wonderful. Can you tell us about your background and journey to STEM that led to winning this prestigious award?
I didn't always know I wanted to be a scientist. And actually, I think some of the roots came from growing up in a small town in Southwest Colorado, where I was really fortunate to spend a lot of time outdoors in the mountains and deserts in the Southwest, camping with my family. And when I got to college as an undergraduate, I took a huge number of different classes in the STEM fields and ultimately realized that I really loved ecology, the study of how organisms interact, where they live, and how they respond to their environment. Still then, I wasn't really clear that I wanted to be a scientist by my career, and that actually was at the start of my Ph.D. I came back to a lot of these forests that I grew up camping in, and actually they had changed dramatically. They looked more like moonscapes of just dead trees reaching up into the Colorado sky. And for me, that was really a turning point. That set the seed of a huge number of questions that ultimately became a lot of my Ph.D. research of what's going on here. Could this be climate change? And is this a sign of the future? And those questions really set my career path in STEM as a scientist.
That's wonderful. Not everyone had always dreamed to be an engineer. I love the passion that set your path. That's really nice. So my question is, what was your initial reaction when you heard that you received this award? Was it like Nobel Prize? Oh, yeah. And what does it mean to you?
I was initially completely floored. I mean, I had to sit down and you get a call. They scheduled a call with the director of NSF. And I really thought this was like there was something wrong or maybe that, I don't know, that there was some program that they wanted me to know about. I didn't have much of a sense that this is what this was about. And I mean, I remember running into the next room to share the news with my wife and my daughters, and it was an incredible news to receive. It means a lot. I mean, you, especially thinking about the number of amazing scientists who have received it before me and folks I really look up to and admire, it was stunning to receive it.
So congratulations. My question is, provide an overview of the research or the project that earned you this prestigious award.
We really try to understand the future of Earth's forests in a changing climate. And that's crucial because Earth's forests really provide huge benefits to society. They harbor the vast majority of terrestrial biodiversity. They provide trillions of dollars each year in things like clean air, clean water, fuel, timber, and tourism. And their future is fundamentally uncertain in the 21st century. And that's because there's these two sets of opposing forces forests are really stuck in the middle of. I like to think of forests really balanced on this knife edge between these two sets of forces. On one side, on the positive side, rising CO2 levels in the atmosphere can help plants and let them do more photosynthesis, potentially grow more, and continue to be a strong carbon sink. So right now, Earth's forests take up about a quarter of the CO2 that people put in the air every year. And this dramatically slows the speed and severity of climate change. It's this huge benefit and subsidy that they provide to us. On the other hand, on the negative side, the stresses of climate change can potentially overwhelm the benefits of CO2. These are wildfires, drought, temperature, and pests and pathogens are some of the big ones that we worry most about. And it's really the balance between these two opposing sets of forces that we don't understand and really has the potential to shape the future of Earth's forests and the speed of climate change itself if Earth's forests start to be more overwhelmed by climate stresses and actually could lose carbon to the atmosphere and accelerate the pace of climate change. Our group really tries to tackle this question from many different scales. We work on lab experiments of plant physiology and how plants respond to stress and to CO2. We work out in the field and take a lot of measurements in the Western US of how our forests are responding right now. And then we use a lot of big data sets and models to try to scale up this understanding, to think about it at continental and global scales. Where might forests survive and thrive, and where might they die off from climate change?
So in this work, what challenges have you encountered?
I think one of the biggest challenges of studying climate change is that the spatial scales and the temporal scales are both so big. We're trying to look into the future over decades, and we really need to understand how these changes play out at ecosystem and continent scales. That's really hard to do in a typical experimental approach. It's also really hard to take this huge complexity. I guess I think the daunting complexity of ecosystems is another big challenge, that there are so many different organisms and their interactions and their unique physiology affects those interactions. So how can we scale up this mechanistic understanding of biology up to the Earth system? And I think that's a big challenge for the field, not just my group's research.
So I have a quick follow-up question. With the large data sets that you mentioned and the scales, is there any thoughts, or what's your thoughts about using machine learning or AI in your work? Or is that something you shy away from? I just wanted to know your opinion about that.
Yeah, we do use some machine learning already on these large data sets, particularly satellite data and some of these ecosystem models. My sense is that there is quite a bit of potential and untapped benefits of using machine learning and AI in these big data sets. But I think there's an important limitation, which is fundamentally our future projections need to be based off of mechanism. And so machine learning is really great at detecting patterns and extracting patterns from huge amounts of data. But the projections and the future forecasts of Earth's forests really need to be grounded in fundamental mechanism. And I think in that case, really machine learning can help us if it informs our mechanistic understanding, not just from a data analysis perspective itself.
Thank you.
So, William, it seems that the work that you are doing is very collaborative. So I was wondering if you can share your experiences regarding this collaborative nature of your work and the interdisciplinary themes that you've been working with, and how has it contributed to your success?
Our work in this broad field of climate change ecology is incredibly collaborative. And I think it's often very multidisciplinary and very multi-approach, very broad set of tools and data sets that we have to bring to bear to answer these questions. I feel mostly just incredibly fortunate to have collaborated with so many wonderful scientists across the globe in this. I think it's a field that is deeply internalized the collaborative and multi-approach, multidisciplinary need. And I've been lucky to work with such incredible folks from, many institutions around the US and around the globe.
So with this award in hand, looking into the future, what are your goals and perhaps new goals and aspirations? And what's your plan in pushing the boundaries of your research?
We are deep in the weeds of thinking about a number of different experiments we could do and the types of cross-system experiments that we wouldn't have been able to undertake without this award. Things like drought experiments in mature forests and trying to link that to mechanistic models. We have relatively few of these large-scale experiments on mature trees. We have much more on smaller trees that are easier to manipulate. I would say also a big piece that we'd really like to do is actually development of tools from a lot of this research. So I think there's a huge need for taking this cutting edge science and these models of how forests respond to climate and actually making that information available for decision makers, whether this is land management agencies, communities who are thinking about or worried about fire or drought risk, or even companies thinking about, how can they manage their landscapes or carbon in sort of carbon market frameworks. That there's just this huge need for science to base decisions in this space. And we'd like to really try to do the cutting edge research, but take that extra step to build tools to engage with stakeholders.
I love that. And can I also ask what this award give you? Is it a certain amount of research funding?
It does. It comes with a $1 million research grant of basically unrestricted research funds. So it's the only grant that I never wrote. So it's a really nice a nice benefit to have these flexible funds that with no specific project pitched.
But I would like to say that you've been writing it all your life. Otherwise, everybody could get this unwritten award. So you've been working towards it and you've been writing it. So
it's true.
But it's a sweet deal. It's very amazing.
Thank you.
Also, I have a follow-up question since this is giving you a lot of opportunities to take your research to a whole different level. I've been thinking this year is a year of open sciences. Are you considering sharing of any of these knowledge and tools beyond disseminating them through publications and presentations?
I think open science is really foundational in this area, because if we want to not only accelerate the speed of scientific discovery and the really societally crucial information that this area of science is providing, we have to have open science. And this also ties directly into the tools that providing all of the data sets and the code that's used to generate these tools in a very, very open science approach, I think is critical to informing decisions. That there's a huge number of proprietary tools in this space that we'll never be able to see under the hood. And it's hard to imagine having a lot of confidence in basing decisions off those. I think we can get so much farther from an open science approach in developing these tools. I think this is particularly relevant in the carbon markets space, that there's a lot of interest in using forests as nature-based climate solutions and carbon markets, but it's not based on very strong science right now. And there's an incredible need for open science and cutting edge science to inform that. And the final thing I'll mention is I've been quite excited. We recently launched a new center at the University of Utah, the Wilkes Center for Climate Science and Policy. And I'm the founding director of that center. And we're really excited to try to bring this open science and tool development to inform decision making.
William, can you share some personal stories or any personal story to your journey that could provide insight into the challenges and the rewards of being a prominent scientist in your field?
Yeah, some of the work that we've done has looked at the scientific consensus around climate change. And one of the early papers that I published was really showing that there's immense agreement, more than 97% among climate scientists that climate change is happening and it's human caused. And this is not a big surprise to anyone in the scientific community, but this had a huge splash outside of the immediate scientific community. I received a huge amount of hate mail from that, and actually some threats from that. And there were whole blogs written trying to assassinate my character and kind of cast all sorts of aspersions of some sort of conspiracy. And a final piece was, it was actually, this all happened a couple months after one of my two PhD advisors, the one that I'd collaborated with this, had tragically passed away, and kind of untimely passed away. And it was an incredible mentor to me and an inspiration to me, and still is. But having this paper come out in this incredibly contentious backlash from what I thought was a fairly obvious conclusion at that time, I think was especially even more challenging. So that was definitely one of the difficult parts in my journey that I learned a lot from and grew a lot from. It was not pleasant at the time.
Thank you for sharing that.
So you just mentioned one of the mentors. I'm sure that there were potentially other mentors along the way. And can you mention who have been your greatest inspirations and mentors, and how they influenced your career?
I am really glad we get to talk about mentors, because I feel like when these types of awards happen, it's an amazing honor, but it recognizes just sort of one individual in this incredible process of science, and that really we're all standing on the shoulders of giants and inspired and guided through this path by mentors. And on the other end of this, my lab group and the amazing group of scientists that I get to collaborate with and mentor also played a huge role in all of this work. So I'm excited we get to touch on the mentorship, the key role of mentorship. Personally, I feel so fortunate to have wonderful mentors throughout the process. In undergraduate, Dr. Terry Root and Carol Boggs played a huge role in getting me excited about science and jumping into climate change ecology. As a PhD student, Steve Schneider was one of my co-advisors who really inspired me and helped me launch my career. And Chris Field was my other PhD co-advisor, and I am incredibly grateful to this day for both of them. And then I've just had so many other mentors along the way, Joe Barry, Steve Pacala, and then now as a professor, folks around campus, folks like Jim Elringer. When you step back and look at how different folks have supported you throughout your career, it's this beautiful tapestry that we have of kind of supporting each other and challenging each other, mentoring, providing skills, providing advice and opportunities. It's incredible.
I love that. Earlier, you also mentioned that you have a wife and daughters. So can you let us know how you balance this very demanding research life and your personal life? I mean, I'm sure that is a challenge on its own.
Yeah, it is certainly not easy, and not always super straightforward. I guess I would say that it's a challenge week to week and semester to semester, and that it's always something that I'm trying to navigate. And I think for me, I really try to be incredibly efficient and effective during the workday. And I have the list of things that I have to get done. And then I have a second list of things that would be good to get done, but I'm not going to stay up or work after hours on them. And so once I've accomplished the have to do list, I really try to give myself permission to just relax and be present and enjoy time with my family in the evenings and weekends. And I really think maintaining this healthy balance and taking time for yourself is absolutely crucial. I try to communicate that to all the folks in my lab group. Science is really a marathon, and if you are always sprinting, you're not going to make it in the long run. And really, it's about taking care of yourself and your family and having that healthy work-life balance for the marathon. There are certainly times when we are sprinting, and that does happen, especially with field work or deadlines and grants. And you just don't want, I try not to be sprinting all the time, because I think then you burn out. And there have been times where I've been pretty burned out.
Yeah, that is an all too familiar feeling for me. So I will work on that. Another list to add, Lucy and Pania. So many young scientists and researchers look up to the Waterman awardee models. What advice would you give to career scientists who aspire to achieve similar recognition and success in their fields? What would you say to them?
The advice that was most meaningful to me that I received in a lot of my training is first around perseverance and resilience, that you will be rejected so many times, even on things that you're really passionate about and think are just incredibly great work, whether it's grants or papers or job applications, right? Rejection is everywhere. It happens to everyone, right? There's no one who evades rejection. And really having the perseverance to take a day or a week or take some time for yourself and recover, but to get back up and to try again and again and again and get rejected and try again. And that piece, I think, is maybe the most underappreciated part of the scientific trajectory. I mean, I do think collaboration and finding the right collaborators that you're really excited to work with. I really recommend writing early and often. So I think the writing part about writing up our research and writing grants is a really key part to succeeding and training yourself and getting the practice, because like all of these other skills, writing is a skill and you get better at it by doing it. And you get better at it by feedback. And also, getting rejected is feedback. You're getting comments back, review comments back. Sometimes they're frustrating, sometimes they're valuable. But really that process of writing early and often and then getting back up when you get rejected, I think were the two best pieces of advice I received. I would say as an undergraduate, I took a huge number of writing classes, creative writing classes. I got a minor in creative writing in addition to doing a human biology major. And I almost feel like those writing classes were a bigger benefit to my career than a lot of the science classes, because a huge amount of what we have to do is to write and to tell stories with data. That piece of being able to put together a story and address a question has been incredibly helpful to me during my career.
I concur. A lot of people are really surprised that for most of my time, I won scholarships for writing poetry.
Oh, neat.
And I tell the thing that you just told, William, a lot of that sitting down through things, developing a story came from all of the practice of writing poems, writing these creative stories, and a teacher telling you, pretend you're on the bus and you're having a conversation with a stranger and do it in third person. And so I think it's wonderful. I'm so happy I'm not the person who valued that experience of those creative writing classes. So thanks for sharing that.
Yeah, I don't think I've shared that really ever before on an interview.
And I would totally appreciate that as well, because nowadays the way, especially scientists and engineers, when we communicate, is majority of the chances are through writing. We write papers to communicate our new results, and then we write grants to communicate our new ideas. So a lot of that is really through the writing. And I often also tell especially young researchers, and I tell them, I said, your idea is only as good as your writing. So it's really important.
I like that quote. That's great.
Thank you so much, William, for joining us and sharing your insight about your journey. And congratulations again on receiving this wonderful award.
Thank you so much for having me. It's been a pleasure.
We hope this episode has shed light on the limitless possibilities within the realms of science and engineering. Remember, innovation knows no boundaries, and the pursuit of knowledge is boundless. Stay curious, keep exploring, and be the change you wish to see in the world.
Thank you so much for listening. We hope you enjoyed this conversation. You can follow us on Facebook and listen to our latest episodes on iTunes, Spotify, or Amazon Music. If you're interested in being a sponsor, then please contact us at sponsor@thisacademiclife.org. Join us next time for the good, the bad, and the ugly of this academic life.